this x is greater than or equal to 0 thing, that's just there to cover them, right? Saying that because what I'm going to end up having to do here is take some sort of even root, and I'm not allowed to have a negative under it, so this is fixing it and saying, okay, well, we're not going to have a negative underneath there. All right, so you don't need to deal with that when you're dealing with the inverse. We're only interested in this. So what's the first thing that I want to do to that when I'm trying to find its inverse?
Y equals negative x.
Write it so that it's easier for us. Then what? All right, now what?
Divide by, right?
Uh-huh.
Do that negative something.
Yep. So if I divide both sides by -1,
X minus 1
close. This is going to be a y to the fourth. But if I have an x divided by -1, what is that? Not x minus 1.
Negative minus x.
Yeah, it's just like a negative x. Okay, now what?
Fourth both sides.
Okay, if I fourth root this side to give me a y, then I got a fourth root this side. That's a 4. All right, so I get the fourth root of -x. All right, now, for our fixer, what are we going to have to say that x has to be?
It's got to be greater than 0.
If it's greater than 0, I could get a -3 under here, or a -7. And I'd have to be taking the fourth root of that. Can I do that?
It's
So,
got to be less than
so x
0.
has to be less than 0.
And I think that would that be the domain?
Yes, actually, that is the domain.
So just switch.
Was it asking for that in this section?
Some of them did.
Okay, I'm not going to do that if you want a quiz. I just want you to write the inverse, but
All right.
yeah, good to know.
So the inverse is
Y equals, well, this is just the part that tells us what x is allowed to be, just like they did up here. It wasn't really part of the function. It was just a thing to make sure that we didn't get a number that I wasn't allowed to have.
we need to do that on the test.
No, I think I would still be okay. Like I said, I'm not going to ask you for the domain, so you're okay.
So when it says inverse functions, you just flip x and y.
Right. Yep. So you want to take it out of this f of x format and just turn that into a y. Flip the x's and the y's, and then resolve for y.
And then if it's okay, it's square root. If it's square root, you root it to both sides, so cancel out the square root on one side and puts it on the other side.
Right.
So it'd be rooted, and then how'd you end up getting rid of the fourth root?
The fourth power.
Well, on the left side.
Before the.
This is my answer. This
Oh,
is
that
it.
is your answer. Okay.
Yeah, this is just the domain fixer,
Okay.
so that I know that I don't end up with a negative under here.
Okay.
Right. So if you don't think of this as being something extra, think of it as being an addition, just like they did up there. So we'll say that x has to be less than 0 as part of it, just like they did. Here's my function, comma, here's the things that are going to make sure that I don't get something bad happening here.
If we forget to put that x less than 0, is that minus points?
No, because I'm not going to ask you for the domain.
Okay.
Okay, but for this one, we just wanted to make it look like that. Okay, so same section, so I just want to rewrite this. Okay, swap them. Okay. Okay. So now I've got y to the third equals x minus 7 over 5. Okay. All right, now I'm not sure what the back of the book was going to say for this one as an answer. But I'm going to tell you that I don't want this as an answer. Right, because I'm going to have a root in the denominator, because we know that this really means that this is the cubed root of x minus 7 over the cubed root of 5. And the cubed root of 5 is unacceptable down there. So what I need, what is a perfect cube that 5 will go into? So what am I going to have to multiply everything by? Okay, cubed root of 25 over the cubed root of 25, because we know that's just a 1 in disguise. Okay, so when I multiply across, then I'm going to get the cubed root of 125 over. All right, now what am I going to get up here?
25x.
Okay,
Yeah.
25x minus 175. Where did that come from?
125. The one under Scott's.
Well, yeah, because you're multiplying this underneath the root times this. So I had an x minus 7 times that 25, and we had to distribute, and that's what we ended up with. All right, what is the cube root of 125? Okay, and I'm okay to have a whole number down there, and the numerator's allowed to be as ugly as we want.
So how'd you get x to be? Well, how'd you get 175 then? You just cubed 25?
All right, when you have two things multiplied together that have the same root, all right, you multiply what's underneath them together. All right, so look at something similar but more simple, like the square root of 3 times the square root of 2. What are you going to get for that?
6.
Square root of 6. Okay, so your answer is still underneath that root. You just took the two things underneath it and multiplied them together to get that, right? So that's the same thing that we're doing here. Since I have the cubed root of this times the cubed root of that, you take the two things that are underneath the root and multiply them together. So we did that by distributing here, and that's where that came from.
Okay.
Yes?
How do you know when to do the extra steps?
Anytime that you're going to end up with something that doesn't have a variable in your denominator and it's underneath a root, you're going to have to fix it. Now, if this was a 5x under there, you're okay to leave it. Why is it okay then?
Because you don't know what X is.
Yeah, x could be a 5, and that would be square root of 25 down there, and then you'd be all right. Well, actually, cube root.
Any cube root.
Let's say it was a 25. We don't know. So if that was a cube root of 125 down there, then we'd be good, because that's really just a 5, like we had already. So as long as there's a variable in there, you're okay. But no variable, you got to rationalize it.
That makes sense.
Okay, despite popular belief, there are two ways to do this one, and we'll do them both ways. What way do you guys like doing them best? The swapping method or the composition method?
Swap.
Okay, me too. All right, so there's actually two ways to do the swapping method, because, no, one way to do the swapping method. But you could start with either one of these, I guess. Okay, so if I go f of x equals negative 2x to the 5th, we know that that's really y equals negative 2x to the 5th.
Swap.
Okay? Now what?
Divide by 2. Negative 2.
Okay, so if I divide both sides by negative 2, I get y to the 5th equals
X minus
an x over negative 2.
Equals.
Right, and when you divide, make sure that you're not actually subtracting them.
Okay.
And then I'm going to get y to the 5th.
So now you're going to
Okay. And I get y equals the 5th root of x over negative 2. Is that the same thing as this?
Yeah.
Yes, it is. All right, now, for me, this is not rationalized, because I technically have a 5th root of a negative 2 down in the bottom,
Yeah, you can.
which I wouldn't accept. But that's where they stopped. All right, so that's where we'll stop too, because I've proved that this is the inverse, that these two are inverses of each other, at least the way they look now. So I don't have to keep going. That's one way to do it. Now, as we were practicing a little bit on Friday, the other method, and I think some of you guys kind of liked it, with the composition method, you can take one of these functions and put it in the other one. All right, so if we go f of g of x, right, in other words, I'm taking this g function and putting it in for that x. Okay, well, how will I know whether they're inverses or
No,
not?
that's gonna be easier.
What do I end up with when it's all said and done? Just a plain old x, and that is considered proof. Okay, so if I take this thing and I plug it in there, I'm going to get negative 2 times this monstrosity.
It's a big word.
Thank you.
That's just cancel out.
10th grade vocab word.
Yeah.
All right, so the 5th root to the 5th,
Definitely
Yes.
cancel.
yeah,
Cancel each other.
these cancel. So now I've got negative 2 times negative x over 2. 2's cancel. So now I have a negative, or the opposite of negative x. And that shows me that they are inverses of each other.
Wait, why does that negative stay there?
This, I just canceled because I canceled the 2 with the negative 2, so what was I left with here?
0.
Negative.
Negative 1.
1.
And a negative 1 times a negative x is a positive x. Got it? Okay, 4, we could have went in the other order. G of f of x, right? So that means that I would have to take this thing and put it in here. If I did that, I would end up with the 5th root of negative 2x to the 5th over 2, and I have a negative out in front still, just like this one. All right, well, what do I get to do? Cancel out here first. Not yet. 2's go, though. All right, so now I've got the 5th root of the opposite of negative x to the 5th over 1.
Same thing.
When you have a negative and a negative next to each other, well, you know that is what?
X.
To the 5th.
It's just going to be positive, so x to the
And then
5th.
those cancel.
Those cancel, and I'm just left with x. So it works both ways. Usually sticking one inside the other one is one of the directions is easier than the other. Right, so in this case, for me, going G inside of the F was a lot better than F inside of the G. Okay, we good with those?
Yeah.
Because I think that was the only one that might have been the only verification type that was in your homework.
I think so.
Okay, only one word direction for this one. It says solve. So,
Do us
Rewrite it.
5.
I'd rewrite it first.
Subtract 5.
Subtract
okay,
5.
we'll do this one twice. Okay, and I could subtract 5 here. So I have 3 times x plus 1 to the 1/5 equals 6. Okay. Okay. Now, when you say 5th root it, do you mean to take this thing to the 5th root, or should I raise it to the 5th power? Power. Right, we'll do this one twice so that you can see. But if I take this whole thing and I raise it to the 5th power, now I've got a power to a power, and that is 1. So now I'm just going to be left with an x plus 1 over here. But if I raise the left-hand side to that power, then I got to do the same thing to the right-hand side. And what is 2 to the 5th?
32.
So what's x?
Subtract 30.
Yeah, you guys did.
Whoa, I got
You guys did
2,592.
a little bit better
Wow.
than I did.
I had no idea what I was doing.
You see what I meant.
Okay, now if we do it, what Andy said first, he said he didn't like this, right? So he turned it into root format so that it looked like 3, 5th root of x plus 1 plus 5 equals 11.
Now subtract.
So it's the same thing,
Wait.
you just made it look.
Yeah, subtract the 5.
And probably this is a little bit easier to see what it is that you need to do.
Okay,
Yeah.
so now you subtract 5.
Mhm.
Yeah.
Yeah, other than that, all the steps are going to stay the same.
Oh, yeah,
3
same answer.
5th, x plus 1 equals 6.
Six.
Then would you,
Divide by-
now you divide by 3.
Yep.
So,
X.
plus 1 equals 2.
And then
your 5th root, or
5th
your 5th, your square
power.
power, whatever.
Right, so this one's a lot easier to see that the way that you get rid of a 5th root
And then those cancel.
is to raise to the 5th.
Equals 32.
There you go.
Right, equals 30. That makes sense. I like Andy's way.
Yeah. As soon as I see a fraction like that, I just rewrite it.
Yeah, usually when you're solving for them, when you're solving for the variable, putting it back in root format is your best bet.
Sometimes it will work nice like that. Other times it won't.
Can you do one of the graphing ones?
Yep,
Just one of them. Or we can just wait. until
we'll see.
the next
If you
page.
guys, there might be some on the next page.
Is there
Yeah, there's 4 of them on the next page.
really?
There's 4 graphing.
Okay, Now again, this is one where we're not really interested in changing all of this. We know that this is just a domain thing, making sure that I don't do something illegal over here.
Illegal.
Okay. But, so what's my first step in finding an inverse?
Create one.
And then swap it.
Okay. Now what?
Divide.
Multiply by reciprocal.
No.
I squared it first.
You're both right.
Can
Okay.
we do my way first?
Yeah. Well, I'm still gonna end up doing it his way.
But still.
Because what happens when you divide by a fraction?
Same thing.
Multipliers.
It's same thing. We're gonna end up having to multiply by the reciprocal anyway. Because I'm gonna get these 4s will cancel, these 3s will cancel, and I'll be left with 1.
What about the other side?
Then I have to do the same thing over there. And that makes it kind of nice because then what am I going to end up with over here?
4 times x.
4x over 3 equals a y squared.
I can just square both sides.
Square root both sides. And I'm going to get y equals 4x over 3. And it's the square root of that. Am I good?
No.
Oh.
You got them yeah, yeah.
Multiply by square root of 3.
Yeah, square root of 3.
Good. This one's actually kind of nice because we've already done problems like this before, where you have the square root in the top and the bottom. And we know that it's really easy to fix a square root because you just multiply it by itself. Alright, that'll be my 1. Okay, so what am I going to get down in the bottom then?
Square root.
Which is, okay, and then in the top,
12x.
12x. Good.
But you don't have
You
to,
4x. 1/3.
Good. And I'm okay with this as an answer. All right, now I would rewrite this thing first. When I put something to the 1/3 power, what's that really mean?
Third.
Cube.
Third is root.
It's cube.
Third root. Good.
Making the S.
So this looks like this. 3 times the third root,
X plus
cubed
4
root.
plus 2.
Okay, and that is going to be easier to deal with.
S.
So you see how there's a 3 in front of the third root?
Mm-hmm.
Does that mean it's going up, or does that mean it's coming
It's
down?
stretching it, isn't it?
The 3 out in front.
Yeah.
Stretch.
The
It's
3
stretching
is going to stretch the graph tall.
Okay, yeah, that's what I
The
thought.
bigger the number, just
Isn't it if it's like above 1 or something like that? Or
Yeah.
above?
Right, as long as it's bigger than 1. Like, don't just say that if it's a fraction. Because if it's 1/2, yeah, that'll squeeze your graph down. Okay? But if it's 5/2, that's still a fraction, but 5/2 is bigger than 1, so it's really pulling it. Okay. So what does this -2 do to my graph?
Down
down
2?
to.
That one's, okay, that was, the 4 is left 4.
Right, even though it looks like it should be right 4, it's really left 4. And the 3 we just talked about, stretch. Now, I don't think that these things need to be perfect. They are just going to be sketches. All right, but your original graph
It's 1. I don't know, I forget.
looks like the S. I heard some of you guys say that when we first started.
1/1 and 8/2 or something like that.
Yeah.
Do you have to graph those, or can you just kind of make it?
You sketch it.
For me, I do. Because I still go back to what I did when I was your age. I still remember that far, so that's good.
You don't have to
Sometimes it's difficult. All right, so I always sketch the original first, and then I start shifting it around. Okay. So, all right, so we know that this is my original, and now what should I be doing to it first? Which ones of these? Stretches first. So remember, it's taking it, now the 0, 0, the x-axis is going to hold firm, right? And you take everything else and you pull it away from the x-axis.
Oh,
So it's going to look something like
that's what it means
this.
by stretching. Okay.
All right, and then we're going to kind of move things around in reference to where the origin used to be.
So now let's move that
Down
Down to
and to the left.
in the left 4.
That's cool. You can try.
Yes, unfortunately you can't do that on your paper, but you can do that on here.
to.
So, and if you do that where you give me the original, right? Especially since it's all going to be in pencil or whatever, make sure that you let me know which one you want me to grade. So for me, I would say grade blue.
Once you're on the iPads, you know, then we could do. So.
I don't know, the last time I made a comment like that when she was here, I got the smartboard the next year. So I said, man, if I had a smartboard, then I got one. So.
I mean, on the iPad.
Guys,
Ah.
we're looking at them.
It's pretty technical.
So on the test, I'll just put gray.
You might have to. But if you want to use pens, I got lots of pens up here. I have crayons if you really want to go back to elementary school. And markers and whatever. So whatever you want to use. If you guys really want to use color, you can.
Can we like highlight our answer?
That's okay too. Yeah.
Gray.
Whatever it takes for you. Whatever it takes for you to let me know which one it is that you want me to grade if you've got multiple on there. Most of you guys, you don't need this crutch like I do. All right, so most of you guys just kind of graph it, either that or you move the things around and then erase the ones that you don't want me to grade.
I erase.
Either way. Where does that put me?
X plus 4, or you know what I mean?
Close.
You have -2 squared.
Okay, listen up. All right, I want to rewrite this one so that it's the way we like to see it.
So it's gonna be
Square sign.
Uh-huh.
And then -2x. And then out of the thing is plus 4.
Okay, so I actually still have 3 things happening to my graph here. What's this do to it?
Makes you go down.
Up
Up
4.
4.
Sorry,
Would you switch that sign to?
I didn't. Up 4. It kind of looked like a minus still. All right, what does... All right, I got nothing going on inside, so that means I'm not shifting left or right. But the 2 is doing what?
Shrinking. No,
Nope.
no, stretching.
Why is it a stretch and not a shrink?
Bigger number.
Bigger than 1. All right, so this is a stretch.
But it is going to be
But it's a negative.
It's going to be reflected.
Oh.
Yeah.
Oh.
The negative's a reflection.
So the negative is completely different from.
Yeah.
It's like they're separate.
Correct.
Okay, I was reading.
2 completely separate operations, and it's going to be reflected over what?
The X.
So it would be basically down negative. It would be -4. You're reflecting it. Right?
No, because remember, we have to do these in a specific order. So we reflect, then we stretch, then we shift. So no matter what, it's still going to end up 4,
It's gonna end up 4.
but it's not going to look like it's original anymore.
It's not going to cross the x-axis of the negative.
It's just gonna be the opposite way. So
Okay, so we know that the original looks like this. Let's see. 1, 1, 4, 2, 9, 3. Okay, looks something like that. All right, so out of these 3 things, which ones do I have to do first?
Reflect.
Reflections always come first. So instead of being like this, it's going to reflect it down here.
Stretch.
And then you make it.
Then we're going to pull it. So what's that going to do to it? How so?
What?
Down.
Stretching.
Like this. All right, and I know that's not perfect because it's not hitting the points that it needs to, but you guys just need to sketch it. So I'm just interested that you know what each one of these functions does. And then what?
Up 4.
Up 4.
1, 2, 3.
But what are you moving up for? Just okay.
Up 4 first.
I don't understand which way you like. I get it when we do like the touchdown and all that stuff, how you like stretch it and shrink it, but I don't get when like stretch and shrink when it comes to these, like which way it goes. Like when you
Tell me again.
when like I don't understand like which way you like stretch it or shrink it. Like when I thought you stretch it, I thought you like made it like longer, but you just make.
Okay.
It's like
Whenever we talk about stretches, and maybe we should be more specific when we write this, these are vertical stretches or vertical shrinks. So that means that everything's happening up or down.
So nothing's happening like this.
Not when the number's out in front. When the number's in front of the x inside the function, then you would be pulling them the other way. But we call that something else. We call that a period change. And really, we haven't done any functions that deal with that yet. You will next year.
Okay.
right? Because right now we're talking about things that only happen once. Right? When we talk about period changes, the other word for that is frequency. So if you think about like, if you ever seen like a voltmeter, like when you hook it up to electricity and it does this, okay, and you have a frequency, those are really just sine curves. And you'll be graphing those next year. But they happen over and over and over, like it just keeps repeating. So having a frequency or a period makes sense, okay? So then you can take those things and you can vertically stretch them, which we will, and we'll still call it a vertical stretch, or we may use another word called amplitude change or an amplitude stretch. That means stretching it up, okay? Or you can have a period change, which if it's a period stretch, then you'll take the graph and you'll make it so that it goes like this, okay? Or you could have a period shrink and push it in this way so that it does it up and down more often, right? See, we're talking about a square root. It's only happening once. So it doesn't make sense to have a period change because you'd only be changing the one time it happened. All right, so that's why we really haven't done problems that deal with them. Okay.
So I have to know right now is just I'm working like this way.
Right, and everything's going to be vertical, just like when we did with the parabolas with this, right? Remember we had the vertex being held down by here. So if I had a power that was bigger than 2, it would take the thing and it would stretch it, right? Now it looks like it got skinnier. In it visually it does, but that's really, it's not that we're taking the thing and squeezing it, it's that you're taking the graph that you had and you're pulling it. And when you pull it, it gets thinner, okay? Same thing as if I have my regular parabola like this, and we have a fraction out in front, right? And we shrink it, so you push down on it. So what happens to it? It gets fatter, but we're not really pulling it out this way. We're taking what we had and squishing it, and it makes it go out.
That's
Okay.
it, and then that's
That
the
makes
number
sense.
bigger than 1.
You push on it if the number is less than 1. You stretch it if the number is bigger than 1.
I thought there was less than 1. It got skinnier.
When we had the 2 out here, it got bigger.
Yeah.
Like it would have gotten skinnier.
Right.
Okay. You want to pull it by a factor of 2. Your y's changed by a factor of 2. Right? If your y's changed by a factor of half, that means that they have to get smaller. And that's going to squish it out.
Yeah.
Okay? Right? The main thing to recognize here is that nothing changed from when we did parabolas. Like, yeah, our starting graph is different, but all the rules are still applying as when we graph parabolas. Okay. That's not it. All right, here's a case of a problem that we can do several different ways. All right, although everybody's first step is pretty much going to be the same.
At 2.
At
At
10
10.
first.
Yeah.
Really get 2.
Okay, so that means I'm going to get an x to the 5 halves equals 32. All right, now, several ways to look at this one. That's one thing I could do is rewrite it. So let's do this a lot of times. All right, Andy says rewrite it. So what is this going to be in root form?
The square root of x to the 5th.
Square root of x to the 5th equals 32.
I put it on the inside.
You put the 5 inside?
Yeah, can you do that?
You can. I think you'll hate yourself more, but you can do that.
Why would I hate?
We're going to do this several ways because, well, if you're going to be calculator dependent, that's a good way to do it. So
No.
I don't want it. We'll do it again.
Well, no, I
Don't
already
worry.
wrote it.
I think I know why.
Can we do the other? I already wrote this. Please. Okay.
These mean the same thing, so it doesn't matter whether your power is on the outside or the inside, right? It's just going to change the order that you fix the things. All right, so if we did this one first, what would I have to do in order to start getting the x out of there?
I would raise it to the second or square it.
Okay, so I'm going to have to square both sides so that I can cancel this out. That means I have to square this. All right, 32 squared off the top of your head.
It's a big number.
Yeah,
11, or 24.
1,024. Okay, so you get a big number that you're not familiar with, and then what do?
You explain.
Then you 5th root it.
Okay, then you 5th root both sides so that I get x equals, all right, what number times itself 5 times gets you 1,024?
6.
What is it?
I'm gonna say.
It's going to be,
I'm gonna say like 4.
I think it is 4.
Give me those.
Okay, now for me, that's harder than doing it this way. Because if I was going to do it this way over here, what do I get rid of first?
Get rid of
The 5.
Going to get rid of the fifth root.
Okay, so you fifth root in.
I mean the fifth power. So I would fifth root this side
Wait.
so that this cancels.
Whoa.
And you fifth root, so it'd be 2.
Right, so now I've got the square root of x equals 2.
And you square root both sides.
Then I would square both sides.
Oh, that's okay.
So I'm going to get x equals 4. And I like that way, if I'm going to do this, I wouldn't have done it either one of these ways when I looked at this problem. But if I was going to pick one of these two, I would pick this one because I don't need a calculator for it. Right, keeps my numbers small when you put the power on the outside.
See, I tried fifth using the other one.
All right, now that's 2 methods to try. I don't like either one of those.
Well, see, the same method you did, I tried to fifth both sides, but that was for a evil math move. So I got a completely different answer.
Now the way that I think about this one is I look at this and I know that I want my answer to say x equals whatever the answer is, right? So this is x to the what power? To the first. So I would like this to be a 1. What can I raise this to in order to make it a 1?
2 over 5.
2 or 5.
Could you just,
So now I'm going to have x,
32, and you just raise that to that, and that's
and then I would change that into root format, which is the fifth root of 32 squared. What's the fifth root of 32?
2.
That's what I would have done. But all 3 of these are good, so whatever one you like best. But that's one of those cases where I think raising it to the power is a lot easier than having to do these things. We have any other quiz? So I've got several of these problems that are similar to things that you'll see on the quiz. There's really only 3 different types. Find an inverse, solve, DJ's favorites, and graph.
Can I do one of the solves on the board?
That's what these are here for. So you guys can do them. All right, but if you're going to come up here, you have to teach them.
Oh yeah, I love teaching.
I know.
Can we solve it on our own first before you teach?
I'll do one, whichever one you want.
Okay. Well, let's do a solving one first.
Wait, can we solve it on our own first?
Sure. Why don't you guys try to work? Let's look at this one first. So why don't you try to work this one out on your own? Take a couple minutes, and then we'll have DJ teach you.
-3, and then you have to plug it back in to see which one.
Okay, class.
Sweet chord.
It is.
Why'd you pick this one?
Professor Ricardo, ready when you are.
Excuse me, kids. You guys ready to learn today? Okay, so Spencer, what's the first step that you do?
First step that you do is you square both sides.
Okay, smart thinking. Square it. So okay. Now what's next?
Andy, what'd you do next?
Then we have to factor.
You squared the right side, right?
Yeah, that you can't.
So that root's not there.
Oh, my fault. Sorry about
Come
that.
on, Ricardo.
Okay, pretend that's not there. Okay, what's next?
Now it's factored out. So it's going to be x minus 4, x minus 4.
Oh.
So what did you get?
Foil it, and I got x squared minus 8x plus 16.
You said minus.
Plus 60.
Plus 16.
Okay. Okay. So what do you do next, Craig?
Then you have to add -10 and plus 3x.
What?
Add -10 or minus -10.
Okay.
Just minus 10.
And a 3, a positive 3. And that cancels out. And you have to go on the other side. And minus -10 plus 3. So it should be 5x.
So it should be minus 5x
And plus 6.
plus 6 equals.
Okie dokie.
And you have to quadratic that because of foil.
No,
Yeah.
foils.
Yeah, it does. It factors.
Whatever.
wouldn't it be
X minus 2.
x that's not fair.
Yep, equals 0.
Mm-hmm.
So what makes
So
each one of those 0?
3 and then 2.
Now, plug those back into the equation because both of those don't necessarily work.
And you go up to the top,
So we plug it in.
and then
Is that right?
you plug in
4 minus
3,
3, 1.
1, and then 10 minus 9 is 1. So 1 equals 1.
Oh, so you got a square root.
Yep.
Oh,
Oh, yeah, so well, it's the same thing.
1 equals 1.
So
So
1's good. 3 is good.
3 is bingo.
It's about 2.
Let's try 2. 2 minus 2 is 2.
A is
4 minus 2.
6.
Yeah, 4 minus 2 is 2.
Yep.
And then 10 minus 6 is 4.
Square root of that.
Set my backwards.
It's
2.
So
So
both
3 and 2 works.
Yep. Doesn't happen very often that they both turn out to be okay, but this one they did.
But you did it right here.
Bingo.
Good.
Any questions?
This is right here.
Nope.
You just
Okay.
got this one, so it should be two.
Totally Sparky.
We'll help you.
Alright, so
Sparky.
for this one, you would want to distribute this cube, right?
Oh,
yeah, no.
Get it out. Get
Or,
it out. Get it
not
out.
distribute, but like put to both sides.
Get it out.
Not yet.
Get it out.
Divide by 2
Yes.
plus America. So it'd be x plus 1. Alright, so now you take the cube to that side and this side.
Correct.
So it'd be,
Try rewriting it first. Maybe it look easier if you rewrite it.
It's just a multiplier.
rewrite it as a
Just
how.
do what you were going to do because I think you're okay.
Yeah.
I don't want to confuse you.
Equals.
To the other
Oh.
side. To the other side.
Okay. Careful.
Yep.
Yeah, you want to undo a 1/3. Now I want you to do what DJ said because I think you'll be able to see it better.
Okay.
Change that into root format.
This one?
Yep.
No.
No,
It's 3.
You're not changing the right.
It's okay.
All right, let me see what's right there. Okay. Now how are you going to undo that cubed root?
Cube it.
There you go.
So cube this
You guys
one.
always pick up on that a little bit better when you see it in that root format.
Yeah. So this is no good, right? That's
Yep, but
canceled.
if you did that to the left,
Gotta do it right.
Yeah, I did it right. So cube this.
It's a 3.
Cube that. X plus 1 equals 9. No.
not
Why
that.
7?
20.
You're trying to use that shitty one.
That'd be crap.
All right, now what?
Subtract 1.
There you go.
There you go.
That's your spark.
Yeah. Alright.
Professor,
I'm gonna rewrite this 3x, and I'm gonna get this on this side, so I'm gonna add x plus 6 to this side. Okay, and then I could either, I guess, square it either way. So I'm gonna do that. So now I'm left with 3x equals x plus 6, and I'm gonna subtract x. Subtract x, I'm left with 2x equals 6, divide by 2, x equals 3.
Bingo. Whoa, you do that weird, you act.
So isn't it one of these?
What?
Right?
Yep.
And this is up 1,
Up 1.
and this is left 2.
Yeah.
Let's just do
Just drag it.
Yeah, you can just drag it.
Nope.
Right. So your
Oh.
blue one should also be up there. Drop the pen. And then you can pull it right up there.
You made it 2 pieces.
No.
Yeah. Just undo.
Go for it again. Go for it again.
Hit and undo. Alright. Hit and undo again. And again. And one. Nope. Okay, good. Now grab the blue one. And you should be able to just push it right where you want it.
Woo.
Now you wanted to go up one like the red one, but then you wanted it to go
But-
left two of the
Oh, so it stays there. Right, it's like,
There you
Yeah.
go.
Okay.
There you go.
Great.
Got him.
God bless the smart board. Good.
you do.
Really good.
I'm gonna
I'll do it in
you
person.
in-
Okay.
New
PNA.
Alright, so let me rewrite this.
Record it, man. What you doing?
Recording. It's recording. Professor Burnahan up here.
Yep, so now it's gonna, that'll be x equals -2 over 3y plus 4. Let's subtract 4. Subtract 4. Oh, thanks. X. Where's x?
No, it's not minus 4. It's is it minus 4?
Yep, x minus 4
When
equals
is-
negative
when is
2 over
the-
3y. So we're gonna multiply this by 3 over 2.
I'm so screwed for this.
Multiply this by 3 over 2. So y is going to equal, what is that?
I don't know.
3 over 2x minus some
Right, but
number.
I'm making one change here because that was a negative 2/3. So
Oh, so I
what
gotta
you
multiply.
multiplied by right now, you should have a negative y on the left. Okay. Now. you
So
don't
I'll
have to
actually
worry
have
about
a
that.
negative y.
Not anymore.
Oh, okay.
You fixed it with your last.
So now we'll have y equals a negative 3 over 2x minus,
Plus.
or plus some number.
Well, it's like a 3, it's a negative 3/2 times a negative 4 over 1. So what we
It'd be
get
12
in
over
the top.
2.
Yep, which
So
is
it's
important.
6.
Down to 6.
Yep.
And that. You're right there.
Okay. Oh.
Speed demon.
Rewrite it. So it's in blue. You'll like that better.
So like that?
Now, how do you undo the cubed root?
Oh, balls.
You-
Oh.
One hand PG.
Right?
Yep.
And then I have to do it here
Which you
too.
got to switch them though.
Oh, that's right.
I don't have to switch it yet, do I?
You're finding the inverse. Just do it after the next step. You'll be okay.
So I do that there too?
Yep.
So then,
Good girl. All right.
right?
Yep.
X plus 7.
Let him do it. Come on, man.
Very good.
Is that it?
That's it.
That's it?
That's it.
Yeah.
Good. Good stuff. All right. So you ready tomorrow?
Okay.
Yeah.